Good morning, everyone. Today I'm going to discuss about the distance time and the velocity time graphs from the chapter Motion of grade 9. So first of all, let me take up the concept of distance time graph. Now, this one. In this graph, the line parallel to the time axis is a straight line, and it represents that with respect to time, there is no change in the distance. As you can see in the graph, that at the point of origin, the distance of a body is 100 meter. Then after 1 second, it is again 100 meter. After 2 seconds, again it is 100 meter. And as the time goes on, the distance remains the same. So what does it represent? It shows that the body is at rest. So in this graph, the line is parallel to the time axis. This shows that the distance remains the same with respect to time. Hence, the body is at rest. Now, let me move to the next graph. Yes, a distance time graph where the graph represents a slope and the graph is a straight line. Now, what does this straight line represent? Let us just discuss this graph in detail. As we can see that the origin point when the time is 0 and the distance is also 0. Now, in 1 second, the body covers 10 meters. In another 1 second, the body covers another 10 meter. Then when the time is 3 seconds, the distance covered is 30 meter. That means again the body has covered 10 meter. So we can make out from the graph that the body is covering equal distances in equal intervals of time. So this straight line distance time graph represents uniform motion. A body covering equal distances in equal intervals of time represents uniform motion. So in this graph, the straight line represents that distance increases at a uniform rate with respect to time. Hence, the body shows uniform motion. Now, let me take up the third graph. Now here, the distance time graph is a curved line. Curved line represents that the distance is not increasing at a uniform rate. It is increasing non-uniformly. Like maybe in the first second, the body has covered 2 meter. In the next 1 second, it has covered 5 meter. And in the next 1 second, maybe it has covered 10 meter. So in this case, the body is not covering equal distances in equal intervals of time. So this type of a motion represents non-uniform motion. So in this graph, the curved line represents that distance increases at a non-uniform rate with respect to time. Hence, the body shows non-uniform motion. So once again, I would just like to recapitulate these 3 distance time graphs. A distance time graph parallel to the time axis represents body at rest. A distance time graph showing a straight line represents the body is moving with a uniform motion. And a distance time graph with a curved graph line represents the body has a non-uniform motion. So these are the 3 different types of distance time graphs. Now, let me move forward with the velocity time graphs. So next, we are going to take up the velocity time graphs. And the first graph here is again a line parallel to the time axis. But students, you don't have to get confused between a distance time graph parallel to the time axis and a velocity time graph parallel to the time axis. There is a great difference between the two. Here in this case, with respect to time, you can see that there is no change in the velocity. Right from the time of origin till 4 seconds, we can see that the velocity remains the same. It's moving at a rate of 40 kilometers per hour. Okay, or maybe 40 meters per second. Whatever the numerical value is, it remains the same. So that means a velocity time graph parallel to the time axis represents uniform motion, because here the velocity is not changing with respect to time. So in this graph, the line parallel to the time axis represents that velocity remains the same with respect to time. Hence, the body shows uniform motion. Now the next graph is a velocity time graph going upward straight line. In this case, as we can see that the velocity is increasing from 0 to 1 seconds, it has increased till 20 meter per second. Then in the next 1 second, it has increased to 40. Then in the next second, it has increased to 60. So can we say that the velocity is increasing by a value of 20 meter per second in each second? Or I can say that the velocity is increasing at a uniform rate. So this type of a graph that represents a uniform increase in the velocity is known as uniform acceleration. Remember, acceleration is change in velocity. Now that change can be either positive, positive means the velocity may increase, or it can be negative, that means the velocity may decrease. When the velocity increases, we use the term acceleration, and when the velocity decreases, we use the term retardation. Now here the velocity is increasing, so it is accelerated motion, and the rate of change of velocity is uniform. So I can also say that the body is showing uniform acceleration. So in this graph, the straight line represents that the velocity is increasing at a uniform rate with respect to time. Hence, the body shows uniform acceleration. Now, let me take up the next graph. Now in this graph, again, it is a straight line, but the slope is downwards. Like at the time of origin, the velocity is 5 meter per second. And then gradually within next 5 seconds, it comes to 0 meter per second. So can we say that the velocity is decreasing? So that means it is showing retardation. And the retardation is uniform. Okay, so a velocity time graph showing a straight line which is sloping downwards represents uniform retardation. So in this graph, the straight line represents that velocity decreases at a uniform rate with respect to time. Hence, the body shows uniform retardation. So remember, a straight line going up is uniform acceleration, but a straight line coming down represents retardation. And straight line represents something uniform. Now the next graph. This is a velocity time graph where the velocity is increasing, but the curved line represents that the increase is not uniform, but it is increasing at a non-uniform rate. So this kind of a motion is non-uniform acceleration. So in this graph, the curved line represents that the velocity increases at a non-uniform rate with respect to time. Hence, the body shows non-uniform acceleration. Now I take up the last graph, which is a curved line, again a velocity time graph, which is a curved line and the slope is downwards. So can I again say that the velocity is decreasing, but with a non-uniform rate? The rate of decrease of velocity is non-uniform. So in this graph, the curved line represents that velocity is decreasing at a non-uniform rate. Hence, the body is moving with non-uniform retardation. So today, we have discussed about the 3 distance time graphs, and we have discussed about 5 velocity time graphs. So it's very important to understand how to read a graph. So when you are reading a graph, the first thing that you must consider is that whether it is a distance time graph or it is a velocity time graph. This is the first thing that you must read. And then you should take into consideration whether the graph is parallel to time axis, or if it is a straight line, or it is a curved line. So I hope you have understood the topic. Thank you.